Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to solve inequalities. This is going to be part one of our multi-part series on inequalities. To get us started, we're going to do a real quick review on how to graph inequalities. Okay, so let's do a real quick review on inequalities. All right, so let's take a look at the following inequalities and how to graph them. Now let's say you have x is less than a. How do you graph an inequality of this nature? If you have an inequality like this, basically what you have is an a value on a number line. If you have less than, since there's no line on the bottom, you're going to have an open circle, okay? And less than goes to the left. So any number that is smaller than this a value satisfies this inequality. Okay, so this is less than. That's how you say it. Now, one confusion that students have is they confuse the less than or greater than inequality symbols. Let's look at the greater than inequality symbol and then we'll talk about how to distinguish them. What if you have x is greater than a? For x is greater than a, in this case, you still have an open circle because you do not have the line of inclusion underneath the inequality. So you have an open circle. Since it's greater, you're going to be going to the right. Okay? So less than to the left, greater than to the right. Okay, so this is greater than. So what's an easy way to distinguish between less than or greater than? So let's look at the word less than, okay? If you look at the first letter of the word less than, let's extract that L. Now, if you take the L and you just rotate it a little bit, this vertical part, what do you have right there? You have the less than inequality symbol, okay? So basically, less than L and the inequality symbol, they point to the same direction. And they open in the same direction. They open to the left and they point somewhat to the, they open to the right and it points to the left. Okay, so anytime you forget which is less than or greater than, ask yourself which one looks more like the L symbol. So if you have less, you have this right here. This looks kind of like the L. So that should remind you that this is less and the other is greater. Okay, so that's just an easy way to help you remember which inequality is which. Okay, all right, now let's go ahead and take a look at the inequalities that involve boundary values. We're going to look at x is less than. So this is open circle, where when you include that line right there, that closes the circle. That means the boundary point is included. Okay, how do we graph that? Well, it's similar to less than, but the difference is you include the boundary values. And how do you show that inclusion? You just use a closed circle. Okay? So this one is less than or great or equal. Less than or equal. Okay? And then we also have x is greater than or equal to a. This is similar to x is greater than a, but it includes the boundary value a also. All right? So it's closed circle and everything to the right. Okay? So another way to know what direction you're going, just look at the inequality symbol. It tells you. Okay? Less than is pointing to the left, greater than is pointing to the right, and then you have the other ones here. Alright, so these are the graphs that we are going to be graphing for the solutions of the inequalities that we are presented with. Alright, so the instructions for the problems that we're doing are for us to solve the given inequality, express your answer, express your solution in algebraic and word form, forms. Alright, and when you're done with that, you're to graph the solution and finally check your work to make sure that it is in fact correct. Okay? Alright, so for number 1, the question that we are going to consider is x plus 3 is greater than 5. So let's go ahead and solve this inequality first. So if we want to solve it, we have x plus 3 is greater than 5. Ladies and gentlemen, this is a one-step inequality. What does that mean? You can isolate the variable in just one step. Do you see what that one step is? The one step is simply to subtract 3 from both sides and you achieve the solved state. Okay, so let's go ahead and subtract 3 from both sides of our inequality. So when you subtract 3 from both sides, you will have x. So these ones add up to 0, and you're left with x is greater than 5 minus 3, signs are different. You subtract, and you keep the sign of the bigger of the two, which is positive. Alright, so we're done solving. This is our answer in algebraic format, so let's box it. We also have to write our answer in a verbal form or in word form. So how do you write this inequality using words? Using words, this inequality is written as x is greater than 2. Alright? So that's the word form for expressing your result. So algebraic, and we have the word form. Alright, so what we're going to do next is we're going to proceed to graph our inequality. Let's graph it to the right. Alright, so we're going to graph this inequality on a number line. Okay, we're graphing x is greater than 2. Alright, so there goes my number line right there. And then let's go ahead and graph x. Graph 2, so we can put 2 right here on the number line. So what will our graph look like? Do you remember what greater looks like? Greater than is an open circle and everything to the right. Okay? So we're just going to graph an open circle on top of our boundary value, which is 2, and everything to the right of 2 satisfies this inequality. Okay? So let's go ahead and check our result to see if it's correct. So let's do the check. So to check, we're going to pick any number that satisfies this inequality, okay? Any number to the right of 2 is a candidate to check with, okay? So you can pick any number. I'm going to select 3, okay? So we're going to use x equals 3. As you can see, x equals 3 is within my solution region, which is any number that's what? Greater than 2. Okay? Alright, so let's go ahead and check. We're going to be checking with x equals 3. So we're going to put this into a t-chart because we are trying to write a proof to show that our solution is in fact correct. Alright, so the inequality that we were given at the onset is x plus, write that again, we have x plus 3 is greater than 5. Alright, so how do we do our check? To do our check, what we're going to do is basically take the number that we selected to check with, and we're going to be plugging it into the x in the inequality and checking to see if we end up with a true statement. If the statement is true, our solution is correct. If it's false, then maybe our check is wrong or our computation is wrong or both are wrong. So let's see what happens here. Okay, so when we carry out this substitution, we don't know for certainty if it's true or false. So we're just going to write 3 plus 3, and we'll ask ourselves, is it greater than 5? this inequality indicates uncertainty. Okay? Alright, so let's simplify the left side since the right side is completely simplified. 3 plus 3 is 6. So the question is 6 greater than 5? Absolutely. This shows that our result is correct since this check statement is true. Alright, let's try another example. This example we're about to do helps us to see another difference between equations and inequalities. You might be wondering, well, solving an inequality is very similar to solving an equation, and that's very true. But in what ways do they differ? Now let's consider this equation right here. Negative 2x plus 3 is greater than or equal to 7. Alright, so we're going to solve first. We have negative 2x plus 3 is greater than or equal to 7. Now, this is a two-step problem. This is a two-step inequality. By executing two steps, you will be able to get the variable x isolated. So the question is, do you see the two steps that will result in the isolation of x? The two steps are as follows. You're going to subtract 3 from both sides and then divide by negative 2. Okay? Now when you're dividing by negative 2, you have to be really careful because anytime you divide or multiply by negative, when you're dealing with an inequality, the symbol switches to the opposite direction. Okay? So keep that in mind. Alright, so let's go ahead and execute our steps. Step 1, you subtract 3 from both sides of the equation. When you subtract 3 from both sides of the equation, you end up with, so these ones add up to 0, and you have negative, change the color here, you have negative 2x is greater than or equal to 7 minus 3 is 4. So negative 2x is greater than 4. Alright, now what do we do next? What we're going to do next, we're going to proceed to divide both sides by negative 2. Alright, so divide by negative 2 because we are undoing the multiplication operation between negative 2 and x. The inverse of multiplication is division. Okay? Now when you carry out that computation, you have x. What's the inequality symbol going to be now? As indicated earlier, whenever you divide or multiply by negative, the inequality sign flips. So you have less than or equal to. Positive over negative is negative. 4 over 2 is 2. Okay? So let's give ourselves, write a little note to ourselves so we don't forget. Okay? What's the note? You want to note the following. Note. You switch the symbol, the inequality symbol, whenever you multiply or divide by what? By negative. Okay? Very important. So that's why I'm putting a note to self here. This is one big difference between equations and inequalities. Okay? Equations does not encounter any change in the equation or the equality symbol. But when you're solving an inequality, that original inequality could flip towards the end whenever you divide or multiply by negative. So that's one big difference between equations and inequalities. Okay? So don't forget that. Now this is our answer in algebraic form. So what we're going to do now is we're going to proceed to write down the answer in verbal format or word form. So how do you say this result that we just got here? How do you say this? You say this by writing x is less than or equal to negative 2. This is the word or verbal representation of the results that we just got. Okay, so let's go ahead and call it the word representation. This is word form. Now what we're going to do next, we're going to proceed to graph our solution on a number line. So that's the next part of our work. So let's graph it. We're graphing um, x is less than or equal to -2. Alright, so start off by drawing our number line, and then we're going to graph our boundary value. Our boundary value is -2. So how do you graph greater than, I'm sorry, how do you graph less than or equal? Since you have that equality sign there, that means the circle is closed. And less than, lefty, less than means you go to the left. In the previous question, we had greater than and we went to the right. Less than goes to the left in the direction that the inequality is pointing. Ladies and gentlemen, that's the graph of our solution. Let's go ahead and check to see if our result is in fact correct. To check, we're just simply going to pick any number to the left of -2 or -2 itself. How can we pick -2? Well, you have a closed circle, which indicates that that boundary value is included. Okay? Alright, so let's pick, we could pick -2, but I'm going to pick something else. I'm going to pick -3 because it's to the left. -3 is right here. It's to the left of -2. Alrighty, so we're going to be checking with x equals -3. We're going to be putting this into our original inequality, -2x plus 3 as greater than or equal to 7. And we will see if the substitution results in a true statement. If the resulting statement is true, then we will know that our answer is in fact correct. Okay, so let's go ahead and do our check. We're going to do this by substituting our check value into the x in the equation. Let's go ahead and do that. If we do that, we're going to have -2 times -3 plus 3. The question is this result that we're getting greater than or equal to 7? Since we are unsure, we will indicate our level of uncertainty using the question mark symbol. Okay? Alright, let's simplify this. -2 times -3. Anytime you multiply the same signs, you always end up with positive. So -2 times -3 is positive 6 plus 3. Is 6 plus 3 greater than or equal to 7? Is it? Well, let's simplify the left side completely. Remember, we have two separate sides. So 6 plus 3 is 9. Is 9 greater than or equal to 7? The answer is yes. It certainly is. So since this is a true statement, that shows that our answer is in fact correct. Okay? So that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of inequalities, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other tutorials such as this. If you have any questions or comments, just place it in the comment section below and we'll try our best to respond. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day. Goodbye.